Okay, so let's say, for example, you wanted to evaluate arcsecant of square root of 2 and arcsecant of 2. Okay, so here if you rewrite that, is y equals secant inverse square root of 2. Apply secant to both sides. You end up with, because secant and secant inverse just cancel out, so we know you end up with secant of y equals square root of 2. Okay. Okay, so we know that secant of negative pi over 4 and secant of 7 pi over 4 both equal square root of 2. But just like before, we're not going to use that one because it's outside of our interval. Okay, so secant of y equals square root of 2 is true. Oh, that should be positive pi over 4. Sorry about that. When y equals pi over 4. Okay, and same thing with problem B. Y equals secant inverse of 2. Apply secant to both sides. Secant of y, the secant and secant inverse will cancel out, would equal 2. Okay, so we know that secant of negative pi over 3 equals 2. And secant of 7 pi over 3 both equal 2. But just like before, we're not going to use that one because it's outside of our interval. So secant of y equals 2 is true when y equals negative pi over 3. Nope. Actually, negative pi over 3 and pi over 3 because negative is outside of the interval. So actually this should have one more. Can't believe I forgot that one because that's outside of the interval too. So secant pi over 3 is also equal to 2. Okay, so it's only true when y is equal to pi over 3. All right. So any questions on that one? All right. Oh, he wants to write in. Okay. And we'll do a quick sketch of cotangent. Well, cotangent inverse. Okay, so we have our x and we have our y. Okay, so remember cotangent is cosine over sine, which means sine can't equal 0, which means sine can't equal 0 or pi. Okay, so cotangent actually looks like this, a little smoother than that one. Okay, so this is cotangent inverse of x. Okay. Real domain is negative infinity to infinity. And your range is from 0 to pi. Uh-oh. That should be brackets. There we go. Nope, actually, nope. That should be parentheses because it never crosses those xi. There we go. Okay, so let's say, for example, we want to evaluate arc cotangent of 0 and arc cotangent of negative square root of 3 over 3. Okay, so for A, again, we rewrite it as y equals cotangent inverse of 0. We apply cotangent to both sides. Cotangent of y will equal 0. Okay, which is true when, I guess you could say, remember, cotangent of negative pi over 2 equals 0. And cotangent positive pi over 2 equals 0. Okay, so we know we can't use this one because it's outside of our interval. So we use the pi over 2. Okay, so cotangent of y equals 0 is true when y is equal to pi over 2. Bring that up a little bit. And same thing with b. Y equals cotangent inverse of negative square root of 3 over 3. Apply cotangent to both sides. So we have cotangent of y is equal to negative square root of 3 over 3. Okay, so we know that cotangent of pi over 3 and cotangent of negative 2 pi over 3 both equal negative square root of 3 over 3. Well, of course, we're not going to use that one because it falls outside of our range. Okay, so cotangent of y actually equals negative square root of 3 over 3 is true when y is equal to pi over 3. All right, so any questions on that one? Okay. Ooh, I'm still writing. We have time. I think I'll start on it just to. Yeah, we should have time. Okay, so we have angle measures, arc length, and area of a sector. Okay, so let's say if we have our x and our y. Okay, and we decide to move from our initial side, and we swing it up a certain number of degrees to our terminal side. Okay, so if we kind of get that graph and just separate it, so we have our initial side, our terminal side, we have our degree, and here we have our vertex. Okay. Now the one thing we know about our angle is, if you get 2 pi, that gives you a complete circle. So let's say this is angle theta. If we get that and we go a complete circle, we end up right back at the same spot. So theta can also equal theta plus 2 n pi, because we go around once, that's 2 pi, 4 pi, 6 pi, 8 pi. If we keep going in complete circles, we'll end up right back at the same spot. Okay, so we'll call this theta, I'm trying to think of the, I'll call it theta bar. Okay, so we know that theta and theta with the bar over it are called coterminal angles. Where basically you can either add or subtract 2 pi, because if we went negative 2 pi, you just go the other direction. Okay, so to kind of get a clearer understanding of radians and degrees, because these angles are measured in degrees. Radians measure just how far you go along the unit circle. So let's say if you have x and y, and let's say this is your unit circle. We have 0, you have your pi over 2, your pi, your 3 pi over 2, and your circle of 2 pi. Okay, so the circle, when you're going from here to here, I guess it's probably a little higher. Say probably from there to there. Okay, that's 1 radian. If you plug pi over 2 in a calculator, you'll end up with 1.57 something something something. So if you swing it a little further over, probably about right there, that's 1 radian, or 1 additional radian. So from there to there would be 2 radians. Then from here to here, if you swung it all the way from here and went all the way there, that's another radian, or 3 radians total. But pi is actually equal to 3.14, and it keeps on going radians. Okay, and then it just keeps on going all the way around, where this is about 1 radian, give or take. This is about 1 radian, give or take. And this is about 1 radian, give or take. So you're actually at about, by the time you circle around and get to this point, you're at 6 radians. Where if you go a complete circle, 2 pi is actually equal to 6.28 something 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 radians. Okay, so you have your measurement for radians and you have your measurement for degrees. All right. All right. And remember, when you're going from counterclockwise, your theta is positive, and clockwise, your theta is negative. All right, I'm still writing. All right, so quick graph of that just to kind of get the idea. So 0 pi over 2 pi 3 pi over 2. Remember, that's 90 degrees, 180 degrees, 270 degrees, and a complete circle is 360 degrees, or 2 pi. And that's if theta is positive. Bring that down a little bit. There we go. Now, if theta is negative, you get different readings. Okay, now if theta is negative, you're now going this direction. So now, since theta is negative and you're going that direction, this is now negative pi over 2, or negative 90 degrees. This is now negative pi, or negative 180 degrees. This is now negative pi over 2, which is negative 90 degrees. And a complete circle will bring you at negative 2 pi, which is negative 360 degrees. So if you're looking for negative 270 degrees, and you want to know what quadrant it was in, you go this way, you know it's in quadrant 1, because it's between, where is it? Nope, 270, sorry about that. I'm getting mine mixed up, so that's negative 270 degrees. Okay, so if you want to know negative 260 degrees, you would swing around. You know it's between negative 180 and negative 270, so you know it's in quadrant 3. Quadrant 2, sorry about that. Q1, Q2, Q3, Q4. And this hasn't changed here, still Q1, quadrant 2, quadrant 3, quadrant 4. All right, so any questions on this one? All right, so last, and this will be really quick. Should take probably about 5 minutes. And that's conversion from radians to degree. Between degree and radians. Okay, so to go from degree to radians, you multiply by pi over 180. over 180 degrees. From radian to degree, you just flip it. You multiply by 180 degrees over pi radians. Okay. And quick note, radian is implied. Okay, so if you see theta equals pi or theta equals 2, that just means theta equals pi radians or theta equals 2 radians. If you don't see the degree symbol with the word degree, then they're always going to say that it means automatically that it's radians. All right, that's a little side note. Okay, so let's say, for example, if we want to convert from degree to radian, let's say for A, if we have 135 degrees, and let's say for B, negative 270 degrees. Okay. You just multiply them both by pi over 180. So 135 degrees. Clean that up a little bit. Times pi radians over 180 degrees. The degrees would actually cancel each other out. So you end up with 135 pi over 180. You can say radians, you don't really need the radians. Okay, but if you simplify that, it would be 3 pi over 4 radians. And for B, same thing. You have negative 270 degrees times pi radians over 180 degrees. The degree units of measure cancel out. So you're left with negative 270 pi over 180, no longer degrees, so it cancel out. Okay, which equals negative 3 pi over 2 radians. And then from radians to degrees, you just multiply it by the reciprocal. Okay, so let's say if we have problem A. Say 2 radians, or just 2. And for problem B, 9 pi over 2. Remember, sometimes they'll have radians there, sometimes they won't. Okay, so for problem A, 2 radians, you're going to multiply that by 180 degrees over pi radians, where those radians now cancel out. Okay, so that would equal 2 times 180 degrees over pi. Where did I mess up? Pi degree. Yep, radian to degree. Yep, that ends up being 360 over pi, which is rounded out to about 114.59 degrees. Okay, and for problem B, 9 pi over 2 radians. You're going to multiply that by 180 degrees over pi radians. And again, the radian unit of measure cancel out. So you end up with 9 pi times 180 over 2 pi degrees, where your pi's cancel out. Okay, so you end up with 1,620 over 2 degrees, which is 810 degrees. All right, so any questions on that one? All right, so we're going to go ahead and stop there.